look at going through some exam style questions from Year 11 algebra paper. So this was from an Australian Year 11 high school paper. Some of these questions are from there. So we're just going to go through these ones. Not too difficult, not like the ending questions. These are more of the questions you'll find at the start, maybe in your multiple choice or at the start of your short ends. You know, your 1 or 2 markers. So just go through these ones quickly. Shouldn't be too difficult. Should be pretty straightforward. And yeah, make sure you guys pause the video, try it along, and then look at the solution. So question 1, 2 plus root 3 squared is equal to a plus root b, where a and b are rational. Find the values of a and b. Okay, so obviously what we need to do is we're going to have to expand this quadratic expression that we've got here, which is what I've done here. So 2 squared is 4 plus 4 root 3. So remember, this is our a squared plus 2ab plus b squared. Right, or if you guys remember that. So a squared is 4, 2ab is 2 times root 3, which is 4 root 3. And then root 3 squared is 3. Okay? So 4 plus 3 is obviously 7. So we've got 7 plus 4 root 3. Now, this is where some students may make a mistake. They think a is 7. Yep, that's correct. And they'll say b is 4 root 3. But if you look, we don't really have a number on the outside here, right? We just have a square root by itself. So what we need to do is we need to sort of desimplify, or, you know, this is what we get in a simplified form. So we need to just get this fully in third form, right? So the way we do that is we usually try to figure out what squared is equal to 4. Okay. So we're going to do the opposite. So what's the opposite of square rooting the number? Squaring the number. So 4 squared is 16, which means that the square root of 16 is going to equal to 4. So that means 4 root 3 is the same as root 16 times root 3. Okay. And using our third rules, we know that root 16 times root 3 is just equal to root 48. And now we have this in the same form as we do here. So that means that a is equal to 7 and b is equal to root 48. Okay? It's a pretty simple question. Can be a bit confusing, but I'd say this is probably like a 2 marker in an exam maybe. Okay? Second question. An algebraic fraction. So 3x minus 1 over 4 minus 2x minus 5 over 8 is equal to x. So guys, whenever you have an algebraic fraction, your first sort of intention or your first sort of goal should always be to get rid of the fraction itself. Okay. So of course over here we know we have 4 here, we have 8 here. So we know a common denominator is going to be 8. Okay. So what we want to do is we want to multiply everything through by 8, or we want to, we want to get the equivalent fraction of this into 8. We want to make the denominator of this 8. So what I'm going to do is I'm just going to multiply everything by 8. Okay. So if I multiply everything by 8, this fraction is gone. So that just becomes 2x minus 5. If we multiply this by 8, so I'll put brackets here and then times 8. So 8 over 4 is 2. So we get 2 times 3x minus 1. And then 8 times x is 8x. So we get 8x over here. Okay. Now expanding these fractions, 6x, 2 times 3x minus 1 is 6x minus 2. And then minus times minus 5 is 2x plus 5 is equal to 8x. Bring all the x's together, so we get negative 4x is equal to negative 3, which means that x is obviously equal to 3 over 4. Okay? And then probably a 2 or 3 marker at best. And here, you want to get these sort of questions done pretty quickly. Last question, domain and range question. We've got a function f of x is equal to 2 root x plus 2 minus 3, and we need to find the domain and range. Okay? So we'll see first, we look at the domain. If we think of restrictions, we know that a square root number can't be negative. Okay, so this cannot be negative. X plus 2 cannot be negative. So if x plus 2 has to be greater than 0, greater than or equal to 0, that means that x has to be greater than or equal to negative 2. Okay? So that's pretty simple. All right, x has to be greater than or equal to negative 2. Now for the range, since this cannot be negative here, that means that you can't have a negative square root. Okay, you can't have nothing that you square root will give you negative. So the smallness that this number can be is 0. And then 2 times 0 would also be 0. So the smallness that this whole function can be, if this part is 0, so if this whole part, if the smallest value that this whole part can be is 0, that means that the smallest that this whole function can be is 0 minus 3. So the range always has to be greater than or equal to -3. Okay, so that's your domain and range. All right.